So we're gonna start this straightforward and just try to work on this and see what happens. Okay. So this is pretty straightforward. So sine kx, the derivative of f prime is k cos kx. But we want to re-express this to look like this. So what can we do? And if you recall well, there's this unit circle identity that we could employ here. So here's it. That's it. This is the one you could use, and we could think about kx as t. So what we're going to do is we're going to re-express the cos kx as sine pi over 2 plus kx, and so we have what is required of us. I'll write the kx in the front, and so we have it what is required of us to show that it's equal to a sine kx plus b, where in this case the k is a is k and the b is pi over 2. So now let us move on to the part 2 and see what happens again. We already have results for f prime, so we're going to use f prime equals to k sine kx plus power 2 to show the next step. Let's see what happens. So the f prime is k sine kx plus pi over 2, and our f double prime will be equivalent to this. Okay, as you can see, and we're going to simplify this. Becomes k squared cos of kx plus power 2. And again, you're being asked to show that this is to put it in the form of a sine kx plus b. Nobody says that the a values for the part 1, 2 will be the same. So again, we will employ this property into here, and we'll end up seeing the sign where we treat the kx plus pi over 2 like the whole t, and that's why it becomes the whole t plus power 2, or in this case kx plus power 2. Alright, so we have what required of us. Now moving on to the next part. So let's start by taking some time to read this and think about this, and then you could stop the video now and strategize and think about how you're going to continue on to resolve this. So if you think back what you have done earlier, you notice that actually we have shown this to be true for n equals to 1 and n equals to 2. So we show that f prime and f double prime looks like this. So let me write down the result that we showed earlier in this page so for you to see. Right, so we have shown that the f prime looks like this, and you could check that this is looks very similar. And if you replace n equals to 1, that's what you got, what you will get, I mean. And if you replace n equals to 2, n by 2, and you will get this. So if it's not so clear to you, see this is 2 over 2. And what we are going to do now is to take the f double prime to show that the f triple prime, 3 primes, is also in this form, and then we can then argue by inductive argument that the result as being true. So now here we have this f double prime. We're going to derive the third order, and this will give us k squared, and again this will give us k cos of kx plus 2 pi over 2. I just want to write as 2 pi over 2 to give you perspective. And what we're going to do now, we're going to employ that identity one more time, and you can see now that identity is really the key formula, that key results that we use repeatedly. So 2 pi over 2. So in the identity says that we plus pi over 2 here, and in case you don't remember what that identity is, the identity is this one, is the cos t is equal to sine t plus pi over 2. And so now this gives us k cubed, and this is going to assign kx plus 3 pi over 2. So exactly what is required. If we replace n by 3, then we see exactly this expression here. And now we can make our conclusion, and that is as the statement is true. The statement means this particular statement. Okay, statement is true. We have shown that it is true for n equals to 1, 2, and 3. And so to say that by inductive argument, the statement, or you could say it's a formula, is true for all positive integer, and that's it.